Hello, I guess we'll start beginning, right? So hello everybody, my name is Fujio Turner. I work for Couchbase, right? I just recently started working for them, but I've actually been using Couchbase before there actually was Couchbase. I started using them back in 2010-ish when there were this company called CouchOne and Membase. And then eventually those two companies merged together to create Couchbase. And so as soon as Couchbase was released, I knew it was going to be a big platform. A lot of large companies were going to want to use Couchbase, right? It's fast and reliable. What big company doesn't want that? So specifically, I work for on the mobile side as far as as a solution architect. So I interface with a lot of customers, telling them, pretty much explaining them about how Couchbase Mobile works, right? So one of the fun things that I like to do is I like gadgets and cool stuff, and more importantly, I like to be able to show people exactly how Couchbase works. So this is a little cluster that I built out of my own money, right? And there's if you look at it here, there's 4 little gigabyte i3, right, servers right there. So there's Couchbase, and there's Sync Gateway over there. There's 6 little Raspberry Pi 3s, and this is downstairs. So if you really want to pull some cables to make sure that Couchbase works, it does. And there's a HA load balancer. And over here on the side is called Sync Gateway Accelerator. I'll get to that at the end, but it's a pretty cool little add-on to be able to have your sort of solution here. So I talk to a lot of people, right? And one of the things that I always get is, how do you comparable your solution versus XYZ, right? So what I usually say is really our larger, what I said, value for our product is we're not just Sync, but we're an enterprise solution for you. So Couchbase Mobile, for those people who don't know, who maybe just walked off the street, it's a complete end-to-end solution. So Couchbase Lite, Sync Gateway, okay. Well, there's Couchbase Lite, NoSQL database. There's Sync Gateway, which is the web tier. And there's Couchbase Server, which is sort of the on-cloud or on-premise clustered replicated data storage for Couchbase Mobile, right? So the typical topography looks like a star, right? So you have maybe Sync Gateway and Couchbase Server inside of a specific cloud environment, AWS or Azure. And then you have Couchbase Lite connect to Sync Gateway's URLs and to be able to sync up data when you're online, offline. There's another topography that you can use, is that you can do a tiered topography where you actually can chain Sync Gateways together. So the idea would be maybe I would have one Sync Gateway connected to Couchbase Server, relatively pretty local, and then maybe I wanted to do something where I could do a branch or tree topography where I could do something like this. And probably what I think is one of the coolest features about Couchbase Mobile is that we can also do a mesh topography. So there is no infrastructure. You can actually do peer-to-peer replication. And the next question I usually get after that is, well, can I connect my mesh network to my up in the cloud? And yes, you can. Right? It's not that big of a deal. So the topics I'll cover is, so a lot of boilerplate, how channels work, sort of the past, present, and future of most people's typical mobile deployments, sort of cover also how we can sort of simplify data flow in an organization, covered briefly about push versus pull on as far as replication, and then lastly, scaling. So how does our solution sort of scale for you? So sort of the boilerplate, I know some of you already know all of this, so I'm just going to walk you through for those people who don't know. So let's start off in a world where there is only one user and you have your database in the cloud. So how do I sort of sync up my data? So if you go on the offline mode, all you got to do is sort of journal your changes, right? And then when you resync, you reconnect, and boom, you're synced up, right? So this is a great system, but then what happens when you have to do something like this, right? When you have potentially hundreds or thousands or millions of devices, right? So how does that sort of system work in that world? So most people, right, they do read-side filtering, right? So they have maybe RDMS or some type of database inside their infrastructure, right? And what they do is say, well, what we'll do is we'll identify specific people who have access to specific pieces of information, and then we'll just query our database, right? And then, so what we're doing is sort of a read-side filtering, right? So the problem with read-side filtering, right, is it's actually too slow, right? Because then it's more of a question of how many queries per second can I perform to be able to aggregate those pieces of information to be able to deliver for when people connect to my web server, right? So what we do is, instead of the read-side filtering, right, in Sync Gateway, in Couchbase Mobile, we do write-side filtering. So we partition data at the time of write through Sync Gateway. So the idea is that we identify this concept of a channel. And so, for example, in this, we're going to use the channel mechanism as the owner of that piece of information. So as items come in, they get associated with that particular channel, or in this case, this specific user. So now, it's actually relatively pretty easy to get that person that information, because we already know when they log in who they are and what pieces of information they should get. Sounds good, right? So now that we have this sort of concept of users, we have Couchbase Lite is an active participant in the replication. So it does a pull. And we have so when they do a pull, they have sort of the documents that are associated with their channel. And there's every item that goes inside their database, right, or through Sync Gateway is ordered. So for example, we'll have between 20 and 17, there's 18 and 19. But maybe he doesn't have access to it, right? So now that we have sort of the concept of sort of a private channel, so yellow user has a channel, blue user has a channel, and only those specifically allocated to those users can see those pieces of information. We even have the concept of sort of a public channel, so maybe everybody has access to it, or maybe a small subgroup of people have access to this channel. And then we can even have the idea of sharing channels. So maybe the use case would be, I want to share some piece of information with my wife. Or maybe another use case would be, maybe worker A calls in sick, so I need to reallocate all the work specifically to worker B, right? So now in this, we have the fact that yellow user has access to blue, yellow, and red. So his feed would look like this. Make sense to everybody? Nod your head if you say yes. Okay. So, but this is great, but not every piece of information has different priority or different sizing, right? So what we can do is we can do a pull or filter based off a specific channel or channels. So, and then in the Couchbase Lite world, we can have it set to continuous to have a continuous feed. Or we can pull different channels based off of different priorities. So I can set it every 2 minutes for a blue, and maybe the red one is some marketing information with a large image. And maybe so I want to be very sensitive about their specific bandwidth usage on their device, so I wait until they're on Wi-Fi every 15 minutes or so. So the next thing that I get is, okay, how do I integrate this thing into my current system? So let's say it's actually relatively pretty easy. So right, we have this concept of users, and then we have the concept of channels. What you can have is actually you can have one channel that listens to all or most of your documents that you can pull from, and it could be anything, right? Because Sync Gateway talks REST, and then you can have them connect. And the idea would be this application would feed off this channel and process the information as they come in, and they would query your backend systems like this, right? So the next question I usually get is, okay, Fujio, I believe you. Couchbase Mobile here on the left is awesome, and it's replicated and it's highly available, but the systems on here on my right, maybe not so much. What happens if this happens? So I process 24, I have processed 25, I have 26 in hand, I'm about to operate on this thing, and this thing happens, right? So how do I recover from this? So it's actually relatively pretty easy. You just need to keep track of your last sequence number that you process. So you last one that you process, so get your systems back up and running. And when you reconnect to Sync Gateway, pass this inside of your URL. So I want the feed changes since 25. And now you get 26 and 27, 28, and 29. So it gives you resiliency as far as being able to feed and consume the information from Sync Gateway. And ultimately what you see is you're just another Couchbase Lite user, right, with access to more channels. So I'll go into the sort of the traditional data flow that most organizations go through. So, right, you have your database here on the left, and you have some apps maybe connected to it. And then you have some third-party APIs, right, as your business grows, right? And then, right, 2010 goes or rolls around. What they do is take your website and put it around the app. And apparently, people complain, right? So then you create a sort of a web or mobile URL where you do some type of request response model. And then just like above, you have mobile, you have applications for your internal users, and then once again for your third-party APIs, right? So let's take a look at the first iteration of this thing, right? So it probably will look like this, right? With over here, which would have maybe SQLite, right? And so then you have authentication server, and then you have maybe some data processing, right? And you need some type of caching. I pick Couchbase. You can pick whatever you want. So this is your first method of deployment, right? So your second method of deployment is would look something like this, right? You would have some type of offline requirement where you would have maybe something over here with RabbitMQ, an authentication server connected to SQLite. And then you need to come back, and eventually, right, you need to create some type of buffer queue because you can handle only so many writes inside of your RDMS system here. So this is sort of your second iteration of this thing. Damn it. So the problem with this, right, is when you first look at that last example is how do you do conflict resolution, right? So in that example before, the data was in different states and different queues, right? And we haven't even introduced a second player in this thing, right? So how do you do multiple players updating the system at the same time and at different times of the day or week or month, right? How do you handle success, right? So you have more users, more writes, more reads. Inside of the system that we talked about before, how do we handle that? And then more importantly, right, business says we need new features. We need to we want to invest more inside of the mobile applications. So then they have new releases, new features. That means a new schema. That means a schema migration. So most people in this scenario, what they do is they say, okay, what we need to do is all those features that you want, we can release in 6 months. So let me backlog all of those, and then eventually work with the DBA team to come up with a new schema. So then I can then push the new schema on the device. So then we can eventually sort of migrate and get those features for you. And then I usually ask, well, what are you going to do on the device level for as far as migration? Because do you have a sort of solution that's always 100% successful on the Couchbase or on the mobile devices for the data migration? And usually, most people don't have a really good success story on that. But in our solution, right, we're schemaless, so we don't really have too many schema migration issues to really worry about. So what we can do is we had a model that looked like this, right? So now instead of doing this, right, which is what typical your application stack would look like as your business grows, you're going to have a model that looks like this, right? So then instead of worrying about building all those other things, you can build it inside of Sync Gateway and have specific channels that dictate what pieces of information that you have. So that's great. But it actually points to a larger problem inside of the organization, and that is the truth, or data dissemination inside of your organization, right? So you usually have a database over here with a large app, and maybe some of the smaller apps with even maybe some of their own databases, right? And then you have things like this, where everybody has their own version of the truth, right? So the problem with that is the end consumer probably would see a different view of your company at any given time. So if in the example of maybe airlines, the gate display might say you're on time. Your phone says the flight's canceled, but the person working the terminal says it's delayed. So how do we rectify that? Because ultimately they have their own different versions of the truth, right? So for us, it's actually relatively pretty easy, right? We just use Sync Gateway. And then from Sync Gateway, we just publish the truth. And then we can have multiple consumers of the information, all have version truth. So the benefit behind that is when green app talks to purple app and asks them for that specific document ID, they can know what version they're on to see whether or not they're at the same as far as the timeliness of the data. So, but then I usually get asked, well, if that's the case, what's the value add here in the green app here, right? Because if green app here is just a middleman for sync gateway, what is his value, right? So I usually say, why don't we take a look at a use case that looks like this. So for example, in this one, I have a flight 100 to San Francisco. Apparently there's a flight seat that's open in first class. And most importantly, right, the flight's on time, and it's on the flight San Francisco 100 channel. So the benefit behind that is on my phone, right? I could dynamically listen to the red channel because I want to know if my flight's on time. And then I can have another app that publishes weather information, completely separate, right? Because I can dynamically listen to that because I want to see what the weather looks like in San Francisco. And then I can have the green app. What he can do is he can consume both of those. And his job is to produce the price of that ticket for the first class because I want to sort of upgrade from economy to first class, right? So I can dynamically start listening to the green channel, right? And then after I purchase this ticket, I don't care about listening to the green channel anymore. And then I can figure out whether or not this ticket is actually pretty accurate comparable to my view of the world because I have the idea of this reference of the versions in which it used to compute this specific document, right? So I got this question asked to me, and the question says, wait a second, okay. If the green app can read and write inside Sync Gateway, and that information is stored inside Couchbase Server, and that's replicated internally inside the cluster, and that I even have incrementally hourly backups of data, and I even have maybe a sub-second cross-data center replication to another site, and maybe the green app, you can actually use the SDK and do nickel queries against the database, right? They ask, does the green app need its own database independently from Couchbase Server? So before Couchbase Server solution, the answer was yes, it did. But now it's maybe. So now sometimes when it's no, that means that's a huge savings to a company because now you don't have to spend that money that would be allocated to specific maybe Oracle or SQL servers, right? So the larger idea is people want to start creating basic microservices off the platform, right? So first people start off, most people, they want to start off with some public information, right? And then they have a second source that comes in, and then you would have maybe a mobile device over here. And then usually the second iteration, they have some type of private data that they want to sync up, some PCI, PII data. The good thing is, if some of you have heard before, you can encrypt different databases inside the device, right? So the benefit behind that is maybe the reason why you have multiple sync gateways because maybe the data is completely different. Maybe it's actually in different data centers, and thus it needs different security rules for the sync function. But also the benefit is it doesn't need to be Couchbase Lite, right? It could just be any type of app that consumes that RS endpoint. So let's talk about replication. I talked about cross-data center replication before. There's some pros and cons, and specifically how you want to replicate your data into the Couchbase mobile world. So we have this thing called SG replicate or cross-data center replication. So what's the difference between the two? Well, ultimately, SG replicates across the top from the sync gateway side, and you can have it master-slave or master-master. If you do cross-data center replication, you have on the Couchbase server side, which is a lot faster, but the problem with that is, or not the problem, but the drawback from that is that you can't write on the slave, right? It just makes a lot of sense. So on the sync gateway SG replicate side, it replicates via through REST. You have the option of master-master or master-slave. And more importantly, I think it's a pretty good, fine point about this, is that you can replicate based off of channels. So remember that same concept of channels. So in this case, we know the IP address of the other sync gateway, so we can push to that based off of specific channels that I want to. And the benefit behind sort of this master-master system inversion is that you can actually be offline for a long time and still be resilient on both sides. So cross-data center replication method is, once again, it's master-slave. It's a full database copy of what's on the other side, right? So, and then you only can do reads on that side. Then replication is usually pretty fast, right? Actually, it's really fast, right? The memory replication. And then replication is only usually pretty good for up to like 60 days of metadata information that you can store. So before I show this picture, right? No, it doesn't want to show the picture. So before I showed about chaining sync gateways together, so the idea is with Sync Gateway, right, or SG Replicate, now available 1.3 and above, which is built inside Sync Gateway with a standalone product. You have the idea of being able to maybe have a sort of central source of information that you publish information, and then you can, for data locality reasons, you can push SG Replicate from over here to over here. And in this use case, let's talk about the airline use case, right? Channel A maybe be a flight, so there's people, it needs to take off and it needs to land. So those people over here also need to learn about channel A. So then the next question is, what happens if I have a data center failure? So what happens to these guys over here? So that's a question. What should these guys do if there's a data center failure? Anybody? Anybody? Okay. Yeah, right, super simple. I just go back up that has the newest information anyways, right? So the benefit behind that is, as you can imagine, these items can be anywhere. So they can be in different continents even, right? And then also, since these can be channels can be created and pushed dynamically, you can have, if you have specific data sovereignty laws that you need to abide by. So for example, the German user's information can no longer be pushed out. It's actually relatively pretty easy change, right? You just change how this SG Replicate what channels he can or cannot push, and then it abides by those, right? It's a push from the SG side. So I want to talk about push versus pull here. So what's the benefits between those? I get a lot of this, like you just asked. Why should I push or pull, and what's the benefit of each? So let's look at push. So I'll talk about this in a generic sense here. So then you have an app, just any app, right? And it's a publisher of this information. So this piece of data is going to go to this sort of blue app, and we're doing a pushing method, right? So what happens when we get something like this? Oh, right, the blue app went down, didn't get the message. So then usually I ask, okay, who's responsible for getting the data to the blue app, right? And then in this scenario, usually I get, well, it depends, or it's sort of complicated, right? Or maybe it's sort of muddy, partly because, right, the promise or the expectation is broken. Or then I ask, well, how does the Blue app know if the publisher is even available, right? Because what if there's the Blue app here has just a listener? How does he know that the publisher still is up and running to be able to send a message, because I haven't heard from him for 30 minutes? So most people used to say, well, the Blue app will maybe poll the publisher every 30 seconds or however long, and that's the method that it knows that the publisher's up. Or maybe the publisher send like no-op packets, like really empty packets every 30 seconds to show that it's up and available. And I said, okay, that's pretty good. So let's look at pull. So on the pull side, right, you need to first establish a connection to the publisher. But we already sort of did that in push. So in many ways, pull and push, you just need to do the other half of the work, i.e. after you poll him, ask a question. So the idea is that after you connect to him, the piece of information goes down, right? The Blue app goes down. So in this one, who's responsible for getting the data to the Blue app? It's simple, the Blue app is. And how does the Blue app know that the publisher is not available? Because when he made the pull request, the connection timed out. And then how does the Blue app know what data it needs, right? Well, it's actually relatively pretty simple, right? Either the Blue app queries the publisher or asks for the last sequence number. That's the method that we use to be able to figure out what pieces of information it does and doesn't need. And that's what the thing is, right? We just ask for the last sequence number of 25. So I'll talk about scaling, right? So before 1.2, Couchbase Mobile 1.2, we had sort of a limitation as far as the total number of concurrent users that we could connect to. And it was usually around 20 to 30,000 concurrent users, which is a lot. And it was partly because of the inability for a sync gateway to really scale to large numbers, right? So the idea behind this, and I get this asked a lot, how many concurrent users can go inside of a sync gateway node? Rough numbers is 5 to 10,000. So if you look at what they do is, in Sync Gateway, he does the CRUD operations, he does the security enforcement, and actually he's the one who manages the sequence number, i.e. the 25, 26, 27, as the items get written to the database. And Couchbase Server, right, all he does is just store the information through a key value get and set. And then he also has these things called views, if you guys don't know what they are. If you're from the Oracle world, it's a materialized view. And that's where it identifies what pieces of information are identifying what channel. But the problem with this system is that, once again, since he keeps track of that sequence number, there's actually a physical key shown here of it updating. So it actually has to do 2 operations for it to be a success inside the database. But as you can imagine, what if you have 20,000 inserts per second? There's a lot of contention off of this key. And there's some other factors to consider as why, but this is probably one that I would say that can probably be a real sort of big headache for most people. So then how do we get out of this scenario where we have limited ability to do writes per second? So what we do is, in Couchbase Server, right, we have a distributed system, and we have this great thing called DCP, and that's the replication protocol that we use internally inside the Couchbase cluster. And what it happens is the database is sharded, and each shard has sort of a stream of changes that are sequential. So instead of keeping track of our own sequence number, we just piggyback on this guy, right? And we do that by this thing called Sync Gateway Accelerator. That's that little thing on the side that I said how we can scale it out. And the benefit behind Sync Gateway Accelerator, so it is pretty much Sync Gateway, right? But what it does is it uses some core libraries as far as sharding the data or the stream from the Couchbase server and listens to it. And so its job is to identify items that come in and create channel information off of that. And we want Sync Gateway Accelerator with as close as you can inside of Couchbase server, preferably in the same VLAN, because we want to be able to get that stream as fast as it can. So the benefit behind that is now that what we do is we have a system that looks like this. So each one has segregated powers that are isolated, right? And then we have the ability to scale out these things horizontally. So we can have hundreds of thousands of sync gateways, and then we can have up to, right now, about 64 is the soft limit of Sync Gateway accelerators. You can have more if you want. And then once again, Couchbase server, if you have a 100-node cluster, you're making more money than PayPal. So the idea is, once again, now we segregate the reads and writes and do specific jobs. So now instead of him doing the sequence number, he does the sequence number. All he does is storage, and Sync Gateway Accelerator is the one who's responsible for creating key value access for channels. So there's going to be a specific channel, and then there's going to be key associated, value associated with it. So it just stores it. So then instead of a key view lookup, it's a key lookup, is a channel key, and then multiple key lookups, right? So what I would say now, right? Unfortunately, my presentation doesn't want to show, is that we're really a story of consolidation. So Couchbase server, I get a lot of, well, I have running MongoDB, I can use Redis or Memcached on top of that. And I says, well, I guess so, but you could just use Couchbase. And then the next question I get is, well, how do I query your information? Well, I says, well, query an index. And I says, well, you could just use Nicholson Global Secondary Indexes. And it says, well, what about a mobile solution? Because I need to create a mobile solution now. And I says, well, we already have one through Sync Gateway and Couchbase Lite. And then they say, well, I need to do full text search, so I need to pipe it inside of Elasticsearch or Solr. I says, well, we have search available. Right now it's in DB2, I believe. And then next is, well, I need to use Spark to do analytics off of that. And then it says, now we have a new analytics engine that's available for you. And that's it. That's my presentation. Any questions? Oh, come on, you guys. Yes, sir.
So in your last diagram, your Sync Gateway is actually still talking to the Couchbase server. Should it talk to the accelerator?
No. So accelerator, its job is not to do CRUD operations, right? Its job is just to do indexing of the channels, right? Creating of the channel indexes.
So it just basically upload part of the work from the Sync Gateway?
Yes, it does. And it does it in a specific way. It doesn't use views anymore. It does. It keeps track of the keys inside of the value itself so that you can read the value and do multiple key fetches from that, right?
Thank you.
Right.
So accelerator question.
Yes.
So is it running with a service, or is it on its own little node, or where's it run?
So well, ultimately, right, it's still a Sync Gateway, right? But what it is it uses a specific library called, internally what we use called CBGT, right? So in CBGT can listen to the DCP stream, but it can shard the DCP stream. So each one of those Sync Gateway accelerators can have a little chunk of, or piece of the DCP stream, right? So then now, and as the items come in, right, it can just identify what channels need to be created and just do key value operations on that, right? Make sense?
So the Sync Gateway session cookie that comes back. So if one of the node goes down,
Yes.
when the session cookie is being used by the application,
Yes.
will it? Will that be honored in the second node?
Yes, because once again, Sync Gateway is completely stateless. All it just does is actually write logs. It does all of the storage inside of Couchbase Server. So the actual the cookie or the session is actually the key value inside of Couchbase Server.
Okay.
Right? Yeah.
Okay. Thank you.
Anybody else? Yes.
So my question is on the synchronization. In one of your example, you use the sequence number kind of to determine if the mobile side is terminated. Then when you recover, you find the next one. But
Yes.
Have you considered using timestamp in combination of it, or?
So the problem with timestamp, right, is the fact that what if you're off comparable to maybe to the device itself, right? And then we still need an order sequence. And then if I do timestamp, then I have to query or some type of order timestamp. So I have to do some type of map reduce. So then I need to ask that based off of these specific timestamps, based off of these specific channels, or what. Or I could just figure out as items come in, just sequence them that way, right? So the problem is on the smaller scale, it works really well. On the larger scale, right, well, we need to somehow shard that methodology. And the good thing is we already have sort of a sequence number already built inside of Couchbase Server that we just sort of piggyback off of. So I have a question for everybody. I was hoping to ask this in the beginning, right? So how many of you are currently probably working with mobile data as part of in your enterprise, right? That's 1, 2. Keep your hands raised up. 3, 4, 5, 5. Okay. So how many of you sort of feel like it's going to be a larger part of your organization? So those people who haven't raised their hands. Okay. Okay. Yeah, so the good thing is about half of you raised your hands, which makes sort of sense because this is a mobile workshop. But we have these things called Couchbase Days. I asked this question. So when I first started, maybe about 25% raised their hand. And then in the next one. So it keeps growing and growing. And I have a feeling about 18 months, 75% of you are going to be raising your hands, right? Because it's such a important part of everybody's daily lives. And the good thing is the online, offline capability. I think it's such a great business value add for people inside your businesses. So that's why I'm here to support Couchbase Mobile. So any other questions? Anybody? Anybody want to see the cool server downstairs? It's still downstairs. All right. All right. Thank you, everybody.